Hello all, welcome to Code Hub. Today let us solve the LeetCode's daily challenge and the question is candy. Oh, there are n children standing in a line. Each child is assigned a rating value given in the integer array ratings. You are given candies to these children subjected to the following requirements. Each child must have at least one candy and children with higher rating get more candies than their neighbors. So, okay, these are the conditions. Each child must have at least one candy, and it should be greater if they are having higher rating, then their candy should be greater than their neighbors. Return the minimum number of candies you need to have to distribute the candies to the children. So that we have to minimize the number of candies that we are going to distribute to the children, young children. So let us observe the example test cases. The array is 1, 0, 2. For this one we can give one candy. For this for child 1 we can give one candy. Next, for this the rating of child 2 is 0, which is lesser than the previous rating. So we have to reduce it. We cannot give 0 candies, as the condition 1 states that it should have at least one candy. So we can give 1, but the neighboring candies of rating 1 should have greater than the neighbor, so we can give as 2. Then we can go further, and as the third person have a rating of 2, we have to increase it with the previous value of candy, so we can give 2 candies. So ultimately our answer is 5. Similarly, we can see for the example 2 as well. For this we can give one candy, and next the rating is greater than the previous, so we can give 2 candies. For next the rating is greater than or equal to, it is equal the rating, so we can give either 2 candies, or else either we can give 3 candies. So, but we have to minimize the candy, so we can give one candy here. So here the total candies that we give here is 4. So this is what the basic understanding of the problem. We have to minimize the number of candies that we are going to distribute to the young children, such that they have at least one candy, and if they are having higher rating, they should be give more candies with their comparing to their neighbors. So we can see some cases. Let us take the array 3, 4, 5, 7, 8, 9. 8, 9. As you can see, this is an increasing order. This is in increasing order. The array is in increasing order. What will be the minimum number of candies we will be giving? We will give 1, next we will be giving 2, next we will be giving 3, next 4, next 5, next 6. Since they have higher ratings with their neighbors, we will be giving these number of candies. So we will be saying 1, 2, 3, 4, 5, 6. That's it. And we will sum up all the arrays. It is nothing but 6 into the number of the sum of n formula, sum of n integers formula, sum of n numbers formula, which is nothing but n into n plus 1 by 2. Which is 6 into 7 by 2, which is 7 3 21. So the number of candies here is 21, which is 6, 10, 15, 20, 21. So the number of candies is 21. We have calculated this. Okay. What if the array is decreasing order? We can say we have an array of 5, 4, 3, or else 7, 5, 4, 2, 1. So consider this is the array we are having. So what will be this is in decreasing order. So what will be the candies? We cannot give 1. Next the rating is lesser, so we want to give minimum than the previous. So we can give either 2, and then we can go 1. Next again, since the the third children having a rating lesser than the previous, we have to increase this. We will give 2 here, 3, then here it is 1. Similarly, again the fourth children we cannot give 0, so we have to increase the previous Next, the fifth children also we cannot give zeros. We have to increase the previous values or everything. So what we can observe here is we have for in decreasing order, the array in decreasing order, we have given the 5 4 3 2 1, like that we have given. So what will be the sum of candies that we are giving here is nothing but 5 into 6 by 2, which is 15, right? Which is 15. So 15 candies. So these will be the minimum number of candies that we are going to give here. So what we can consider, we are having 2 2 3 3. What we will be giving here, we will give one candy here, then we will be giving two candies here, then we can either give three candies or we can give one candies as well, right? We can give one candies itself. Next 3, it is increasing, so we will be giving 2 candies. Next 3, we don't want to give 3 candies, we have to minimize the number of candies, so we will be giving the 1 candy itself. So what we can observe here, if we segregate, if we separate these array as segments, consider this as one segment, this is in increasing order, this has one segment, 2 3, this is in increasing order. Next 3, it is separate segment, it is only the one element, so it is given as one itself, leave it. So if we separate this as segments and see, you can see that this is an increasing order, this is an increasing order, and this is in increasing order. Let us have some other examples so that it will be more clear. Let us take 29, then 51, then 87, then 87 again. We can take it as 72, then it is 12. Let us give it as 12. So what we can observe here is, this is the one element, we can give one candies. Then this is going to be increasing order, so we can add this itself to our segment. This is also an increasing order, so we can separate this as one segment. This is this is 87, next 72, next 12. So this is in decreasing order. One is increasing order, one is decreasing order. So we for increasing order, what will be the minimum number of values that we are giving? Nothing but n into n plus 1 formula, n into n plus 1 by 2, correct? Yeah. So we can accumulate this as an left array and right array, right? We from left we see means this is an increasing order, from right we are seeing means this is an increasing order. So what we can ultimately do here is, if 29 we are giving as 1. Next, if we can check whether the current element is greater than the previous, then we can increment the length. Then we can see the current element greater than the length previous element, then we can increment its length with the previous. Then you can see the current element is not greater than it, so we can start again our segment. We will start again. Next, the current element is not greater than the previous, again we can start the segment. Next, again we can see whether there is the current element is greater than the previous, again we can start our segment. So from observing from left, we are calculated the increasing order. Now consider we are coming from right. Consider we are coming from right, we will calculate the increasing order. Here let us have put 1 here. Next, as you can see the this element is greater than the next element, so this is in increasing order, so we will calculate it as 2, then the next plus 1. That's what I'm saying. Next, this current element is greater than the next element in from right, so we can give 3 as well. Next, we will come here again. This current element is not greater than, it is equal, so we will start the segment once again. We will give it as 1. Next, the current element is lesser than, so we will start the segment once again. Next, the current element is lesser than the previous next element, again we will start the segment once again. What you can observe is I just calculated the, we can use this formula and calculate each segment. We can calculate their length, and then we can apply this formula also. Even that code will work, but observing the array as from left and from right, we can accumulate their lengths. We are just accumulating their lengths, the increasing order lengths. And then what we can say is, this is consider this is a left array, and consider this is a right array. What we can observe here is the maximum of the maximum of the current left and right gives, if we sum up all those candies, then we will get our answer, right? We can say 1, then we will give 2, then we will give 3, then we will give 3, again they will give 2, again we will give 1, which is obviously our answer, 1 2 2 3 3 1, right? So ultimately this will be a number of candies. So this will not violate these two conditions. It will satisfy these both conditions. We will be giving at least one candy. So and we will be calculating this. So what we are just doing here is we are declaring a left array of size n and a right array of size n. Then what we are going to do is, from left calculate the increasing length. This is done. Again from right calculate the increasing length, and our answer is nothing but, and our number of candies, our candies is nothing but the max of my left of I and right of I, and we can return our candies, right? So this will be our approach. So what will be the time complexity here? What will be our time complexity here? Order of n, since we are going to traverse the array in one linear time. And what will be the space complexity? We will be using a left array and a right array, which is which boils down to order of n. It is 2 into n. This we can just say as order of n. So we can code the approach. Int left of n, we can declare n is nothing but the ratings dot size, left of n and right of n. Initially we can say left of 0 to be 1. Next we can left of 0 to be 1. Next we run a for loop from first index is from till n, and we can say if my ratings of I is greater than my ratings of I minus 1, then what I'm going to say is left of I is nothing but left of I minus 1 plus 1, else left of I to be 1. So this will separate the segments. Again we will calculate the from right of n minus 1 we can declare, and from starting from the last before index, last previous index, I is equal to n minus 2, I greater than or equal to 0, and I minus minus. What we are going to say, we are going to calculate the increasing order length. If my ratings of I is greater than my ratings of I plus 1, next I am saying that right of I is nothing but right of I plus 1 plus 1, else right of I is nothing but 1. And finally we will have a candies value which is initialized to 0. Next we will run the for loop from 0 to n I plus plus. My candies is nothing but plus equal to max of my left of I comma right of I, and return my candies. This is our solution. So the time complexity will be order of n, phase complexity will be order of n. We can just run the code. It got accepted. We can use the example test cases. It got accepted. We can let's submit our answer. It got accepted. So hope you understand the solution, and consistency is the key to success. Let us see in tomorrow's LeetCode daily challenge. Until then, bye.